Alright, so we're going to have a look at another question from the topic of linearity. We are told to let x equal R3 and let y equal the collection of the following three vectors. We are told to find the span of y. So whenever we're doing a span question, if x is R3 and y consists of these three vectors, the span of y is going to be all of the places that these vectors can get us. Can take us to with scalar multiples, additions of them, etc. We definitely know that whatever the span is going to be some part of R3. So we're going to assume essentially it's most of R3, but there may be some exceptions. So let's have a look. These three vectors, 1, 2, 1, and 1, 1, minus 1, and 1, 3, 3. These three vectors will get us everywhere in R3 if they are linearly independent. If the vectors are not linearly independent, there will be some condition which tells us where the vectors get us. So we need to try and work out if they are linearly independent. One way we can do this is to use Gauss-Jordan reduction. So we can say, with our three vectors, we're going to multiply each one of them by a scalar multiple. So we're going to say C1 times 1, 2, 1 plus C2 times 1, 1, minus 1 plus C3 times 1, 3, 3. Well, this is equal to some other vector, which is, let's call it alpha 1, alpha 2, alpha 3. Alpha 1, alpha 2, alpha 3. So we've got this combination vector. If we expand the combination vector up the top, we're going to have this in different parts. So we will have C1 plus C2 plus C3 as the x component, 2C1 plus C2 plus 3C3 as the y component, and then C1 minus C2 plus 3C3 as the z component. So now we want to solve this system, set it up as a linear system. We want to say this is 1, 1, 1, turning this into a matrix. So this becomes 1, 1, 1, and this is equal to alpha 1, alpha 1. This term, 2, 1, 3, 2, 1, 3. This is equal to alpha 2. And then this one, 1, minus 1, 3. 1, minus 1, 3. This is equal to alpha 3. So now all we need to do is solve this system. So we can use Gauss-Jordan elimination to try and eliminate a row or a column. If we are able to reduce it to a 1, 1, 1 diagonal, then we will have that these three vectors are linearly independent, and then the span will be R3. If we can get rid of one of the rows, it will be a little bit more complicated. So if we can get rid of one of the rows using Gauss-Jordan reduction, then we will have essentially a free variable, and that will give us some constraint on the span. So let's try and row reduce this. We are going to take R2 and it will become R2 minus 2 lots of R1. We're going to take R3 and it will become R3 minus R1. This will give us a new matrix. We've got 2, 1, 3 minus 2, 2, 2. So this will give us 0, minus 1, 1. And then we have alpha 2 minus 2 alpha 1. That's alpha 2 minus 2 alpha 1. The top row is still 1, 1, 1, alpha 1, and then we'll subtract the top row from the bottom row. We're going to get 0, minus 2, 2, and this will be alpha 1 minus alpha 3 minus alpha 1, 3 minus alpha 1. Now at this point we can add two lots, or we'll subtract actually two lots of the second row to the third row. So row 3 will become row 3 minus two lots of R2. So this will give us 1, 1, 1 up the top, alpha 1. And then we'll have again 0, minus 1, 1. This will be alpha 2 minus 2, alpha 1. And then our new row down the bottom will become 0 minus 2 lots of 0 is 0. Minus 2 minus 2 lots of minus 1 is 0. 2 minus 2 lots of 1 is 0. And then we get alpha 3 minus alpha 1 minus 2 lots of alpha 2 minus 2 alpha 1. And now in this third row we have a free variable. So the top two rows are fine, but the third row giving us the free variable is giving us a condition linking alpha 1, alpha 2, alpha 3. So the span is going to be R3 with the condition that this is equal to 0, because it is equal to zeros here. So we find that alpha 3 minus alpha 1 minus 2 alpha 2 plus 4 alpha 1 has to be equal to 0. This implies we have what? 4 alpha 1 minus alpha 1, that's 3 alpha 1 minus 2 alpha 2 plus alpha 3 has to be equal to 0. So therefore we find that the span of this system, so the span of capital Y is equal to alpha 1, alpha 2, alpha 3 included in R3, such that 3 times alpha 1 minus 2 times alpha 2 plus alpha 3 is equal to 0. And this is the solution to this question.